In this lecture, I want to discuss a particular class of solutions to the classical hydrogen atom. I should point out that the solutions are identical to those that you may have learned if you discussed orbital mechanics. If you discussed the solution to the problem of say, the Earth moving around the sun, for example. And this class of solutions is by no means exhaustive. There are many other solutions to this problem. And also I want to point out, and I'll say something about this later, that these class of solutions are not entirely correct, but they do illustrate some important features of the hydrogen atom, which will be important when we return to this problem and discuss the full quantum treatment. So I will assert without proof that a particle moving in the hydrogen atom potential, that is the electron moving in the vicinity of a positively charged nucleus, there are solutions to the equation of motion that give you circular orbits around the origin. And again, these are only one set of an infinite number of possibilities, and the other possibilities include elliptical orbits. On some of the features of circular orbits you may have learned about in your physics class. So it's illustrated in the diagram here. So the particle is moving. The electron is at the point I've circled here, and it's moving perpendicular to it's moving around a circle, and its velocity vector is perpendicular to the vector that points towards the origin. And so there's an acceleration. So when a particle is moving around in a circle like this, there's a vector acceleration here towards the origin, a vector pointing towards the origin. That's the acceleration. I'll just point out the speed remains constant, but the acceleration causes the direction of the velocity vector to change, and so therefore there is an acceleration. Okay. Now, in your physics class, you may have learned that the acceleration needed to maintain a circular orbit is given by a particular equation, and that is shown here. The acceleration depends on the velocity v, and the acceleration is minus v squared over r. Again, that's an equation that you may have learned in your physics class. Now, because of Newton's law, where we say force equals mass times acceleration, the force that must be acting on the electron must be given by this equation. Incidentally, I think I neglected to say the minus sign simply indicates that the force is in the negative r direction. So the force is pointing towards smaller r. That's the significance of the negative sign. From before, we had that with this particular potential, force was given by minus z e squared over 4 pi epsilon naught r squared. Okay, now these two, so the source of the force must come from that potential, and if we simply equate that to what we know the force is to maintain the particle in a circular orbit, we wind up with this equation. And that is, notice that So minus ze squared over 4 pi epsilon naught r squared. The source of the force is equal to mass of the electron, velocity squared over r, simply what the force must be to maintain it in the maintain a circular orbit. So you should notice that there's a lot that we can get. There's a lot of information we can get simply from this equation. In particular, we can see how the radius of the radius of this circular orbit is related to velocity and kinetic energy. So I'll show you this from this equation. We'll do just a little bit of a manipulation. Notice that the left-hand side has an r squared in the denominator. The right-hand side has an r. I can eliminate that. I can eliminate one r, one of those r's in that denominator, and eliminate this, leaving me with the equation minus ze squared over 4 pi epsilon naught